Hey everyone, welcome back to the class, and today we will learn about the basic proportionality theorem. In short, we can say BPT, and we can say this is theorem 1. So we'll be learning basic proportionality theorem. So in short, we can say BPT. I will try to explain this one. This will be the second part of will be as we are learning about the concept video. So I will try to explain from beginning, from at the starting point. Okay. So in this term, we'll be learning theorem 1. This is called theorem 1. If a line is drawn parallel to the one side of a triangle to intersect the other two sides in a distinct point, then the other two sides are divided in the same ratio. So you see, now I will try to explain this one. Okay, first of all, I'm not going to give you proof. I'm just going to explain this one. You see it properly. You have to remember this thing only. You don't have to remember all the theorems. No need to be by hearted. Try to understand. That is the best thing we can do. So they are saying, okay, a triangle. Okay, let us draw a triangle first. This is a triangle. If a line is drawn parallel to the one side of triangle, this is one side of triangle, so I'm going to draw a line, okay, to intersect the other two sides in a distinct point. So as we can see, in a distinct point, it intersected, okay. Intersect means I have a cross corner, okay. The other two sides in a distinct point, okay. Then the other two sides are divided into same ratio. ये कह रहा है ये वाला और ये वाला रेशियो बराबर होगा इसके और इसके रेशियो. Let me give you example. For example, A, D, suppose A, B, C, D, and this is A. So our thing will, we have to remember this theorem, that whenever something is like parallel is drawn to one side, then remember this two things will be like equal. A, D, and DB. I'm just writing this part, AD and DB, okay. And now this part is equal to AE by EC, okay. So these two things are equal. We have to prove this one, okay. So I'm going to start from the beginning. I hope you have understood. This theorem says this one, okay. You see, then the other two sides are divided in the same ratio. So ratio we can write like this, like 1:2. We can write like this, 1/2, okay. So let's start then. Let me write this one. Okay. Okay. So let's write from here, given, okay. Theorem 1 is here, and let us write, okay, given, let us suppose a triangle. I'm writing in short a triangle A, B, C. I think ABC, in which a line okay, a line, because a line is parallel to one side, okay. I'm not going to write, okay, it's better to draw a triangle first, okay. Let us draw a triangle. Okay, this is not exactly that kind of triangle. I don't want this triangle. Why it's very tough. Oh, it's very tough to draw over here for me. Okay, just perfect. So this is triangle. So it says that, okay, let me give a name A. Let me use another pen. This is your B and this is your C. Now it says that a line is intersect. This is intersect, okay? A line is intersect the other two sides in a distinct point, okay? So let us give some name also. This is D and this is your E. This is D, okay? I hope you can see D. So I'm going to write a triangle ABC in which a line DE, because of this, a line D parallel, this is parallel to this line. So I write DE parallel to BC. Can you see? I can write BC intersect, can you see AB at D, because here it's intersecting, okay? D and AC, this AC at E. So I can say that is DE is parallel, this is parallel symbol, and to BC. I hope you understood this one. I have not written anything tough thing. You see whatever written in the theorem, I'm just writing that one, given, okay? So a triangle ABC in which the line DE. So we have just drawn that one, okay na? So if you understood this, we can go ahead. Okay, why I'm moving up? Why it's okay? Leave it there. Yes. Okay. So this is, we need to prove, as I gave you right now, few minutes ago, we have to prove this AD by DB is equal to AE by EC. We need to prove this. Okay. Now the main thing is that to prove something, because triangles are here, we need lot of things. We cannot prove simply. So we have to suppose something. We have to do construction. If you have studied in class 9, such thing needs construction. So let's see. I'm just going to construct construction. We can just write like this. Construction, we can say, we can just making this line, we are separating in a two triangle. Can you see one triangle and another triangle, okay? And we can draw this one also. So we can see this one triangle and one triangle for this. I'm not talking about this line, okay? I'm talking about this triangle. Can you see this one? This triangle and this triangle. So we can see there is two triangles, yes or no? On this one and this side. Okay, na? I hope you have understood that. So I'm talking about that triangle. So we can just say construction, we can say joining BE and CD. Okay. Okay. Now before I go forward, you see, we have to prove this one through triangle only. We don't have any other option, because one triangle and another triangle. Most of the question we prove through the triangles only. That's why I said that triangle is the most important topic. You should learn it if you want to do maths in a better way. So this triangle and this triangle, we'll see. In a triangle, to find out the area in a triangle, we need two things. In a normal way, we have learned from the lower classes, we know that half into base into height. Base means downside, and whatever the height will be there, That is the height. But you can see here, we can get base. Okay, half is already there, base is there, so but we don't have height over here. So for that, we are going to write like this: drawing EF is, this is perpendicular. Perpendicular means 90 degree. Okay, whenever line is like this, we can say perpendicular. So drawing EF and perpendicular B and AB, and DG is, can you see, D, not DG. Okay, it's DG. But I have not drawn anything. I'm just writing EF. I wrote because I suppose the point over here. I'm just writing there is F and there is Z. Okay, so DZ is perpendicular to AC. So I'm going to draw from here to here. I can say perpendicular, so it's 90 degree, and from here to here it's 90 degree. Okay, both sides will be 90 degree only, no problem. You can draw one side also, it's okay. Or if you don't draw this one also okay, because we have already said it's perpendicular. Okay, now we got this. After doing this, we got base also, and now we got height also. If you see this triangle properly, I'm talking about, it will be messed up, you see properly. Okay, let me change the color. If you see this triangle properly, then we got the height, isn't it? We got this height. So this is the height for this triangle. And for another triangle, this one, and up to this and this, the height is this one, isn't it? See it properly, this is the height. So we can do one thing. As we got that, we can write okay, it's very sometimes why it's roughing one by one. Okay, done. So as we can see, we can write over here. We can write easily proof. Okay, let's start the proof. So I'm going to write area. I'm writing in short. Okay, of a triangle A D E. I'm taking this AD. Can you see this is, I'm talking this upper part. This one, okay, this one. This is A, D and E. So in triangle, area of triangle ADE by, because we are talking about the ratio, so that's why we will be writing in this one, by area of triangle BDE. Can you see this one? Because we have this 90 BDE. Okay, if you see properly, okay, we are talking about this one, B D E, about this. Okay, we are talking about this triangle, if you see it properly. So this triangle, so we can write, is equal to half, okay, into base. Let us find out the base. You see, for ADE, okay, I'm going to draw it again. Okay, I'm going to draw here so that you can understand it properly. So we can write A, B, C, okay, and this will be, this is A and this is your D, and we suppose this one as a E. So now you see base of this triangle will be D. So we can write base of this triangle, because it's 90 degree over here. So we can say, because ADE, okay, so we can say base will be this one, wherever this one goes, isn't it? If you see this triangle earlier, so straight, okay, wherever you draw this line, this used to be base, okay. So this line is coming downside, means this is base. So we can write AD into height. If you see, that was there, E and F, okay. So you can see the earlier picture, so we can write E, F. Downside, we can write area of triangle BDE, okay. BDE means this area, BDE, okay. So half, if you see properly this one, here we have the base is this one, because we suppose base for this, then of course another base will be this only, because they are on the same line, if you see properly like this, okay. So if I suppose this is the base, another base will be this, so we can write into DB, and as you can see, there is only one triangle, and this is the height of it, so height will be EF, okay. So as we can see, EF and EF can cancel, upside downside all are multiply, half also we can cancel, then we have already AD by DB. You can give reason, since area of triangle is equal to half into base into height, okay. So this is your formula, which maybe you may be learning from the lower classes, but if you know, then good. If you don't know, then you must learn it as soon as possible. So let's see the another one. So I'm going to similarly we can say area of ADE, upper side only, same this one, we're talking about this area of triangle, okay, ADE by, but this time we have to see this area, because we have already took this area, ये area already खत्म हो चुका है, now this will be this side, okay. हम इस side को देखेंगे, तो area of triangle, this is DEC, okay, DEC, थोड़ा गंदा हो चुका है, I can see that, but you listen it properly so that I can help you. Oh, I think okay. Similarly हम वही करेंगे, इसका भी वही सेम फॉर्मूला होगा, ओके. तो हम फिर से मैं ड्राइंग कर सकता हूँ, इट्स नो प्रॉब्लम फॉर मी. इक्वल टू हाफ बेस इसका होगा ऑफकोर्स ये एरिया इंटू ए, हाइट होगा इसका जो यहाँ से जो एक लाइन बना है ना, ये वाला, यू कैन सी द अर्लियर पिक्चर, ओके. यहाँ पे जो हमने किया था ना, देखो DG इज परपेंडिकुलर, यहाँ पे ऑलरेडी एक लाइन बनाया था परपेंडिकुलर से, ये DG है ना, दिस वाज जो DG, ये जो है, सो दैट विल बी द हाइट, ओके. सो AE into DG, and area of, okay, I will keep drawing the figure, मैं ड्राइंग करते रहूंगा so that you can understand. There A, B, C. One drawing is sufficient for you. You don't have to draw all this thing. This is just for explanation, okay. So earlier we have drawn this one at G, yes or no? And we have drawn this one also. So as you can see, this is the height. Okay, now DEC inside this triangle. Okay, so base will be again this half into, you can say, EC into, and DG is your height, isn't it? Height will be the same, so we can say DG. What happened to this? This is EC, not getting enough also. Why? Okay. It's a E and C. Okay, this one is the base and this one is your height. You can see this and this cancel, half and half also cancel. We got AE by EC. Easy, I guess. It is a little long, of course, but it's very easy. If you write properly, then you can understand. Okay, so we got this EC. So we can do one thing. We can give this one as a equation 1, okay, and this one is equation number 2. I hope this makes sense. Now we have proved this both sides, this side also and another side also, but now we need to prove in a triangle. Well, let me write the triangle. Since triangle BD, okay, I'm just drawing this side, BDE and can you see DEC, they are talking about this triangle. Okay, so triangle DEC stand on the same base DE. Can you see? This is the same base for them. Okay, same base, as we can see, this one. Now same base, and these are between same parallel lines. If you see, this is the same parallel lines, which is DE and BC, which is DE and BC. So since these are under the same parallel line, you see parallel line means what? इन दोनों का जो डिस्टेंस होता है वो हमेशा इक्वल होता है. यू कैन सी द रेलवे लाइंस हमेशा इक्वल होता है. सो पैरेलल मीन्स वो कभी भी इंटरसेक्ट नहीं करेंगे. दे विल बी, दैट मीन्स द पैरेलल. सो इक्वल होने से वो पॉसिबल है. थोड़ा सा भी टेढ़ा होगा कहीं ना कहीं जाके वो मीट अप हो जाएगा. ओके, I need to run this. Okay. So this is your D. So I can write therefore इन दोनों ट्रायंगल क्या हो जाएगा, दोनों सेमी बेस पे है, सेमी पैरेलल पे, सेमी मतलब डिस्टेंस के अंदर है. तो देयरफॉर BDE, एरिया ऑफ BDE इज इक्वल टू एरिया ऑफ ट्रायंगल ये वाला DEC. एंड देन डन. वी कैन से इक्वेशन नंबर 3. ओके, सो आई कैन राइट फ्रॉम इक्वेशन 1, 2 and 3 we get क्या मिला हमें? We can get this one, this and this, because it's under the same triangle. We can just say, and this is also equal, we can say AD by DB, okay, DB is equal to AE by EC. We got this both triangle in equal. You see, since the triangle BD is stand on the same line, so this will be parallel, so this area will be equal. So as we got the equal areas, then of course this two will be equal, isn't it? So this was your BPT. We just need to prove, so we have done it, and hence it is proved. Hence proved. So this was your BPT, and we can do some corollary also on this. So okay, let me do that one also. Hence we proved this one. So now we'll do a corollary. Now I hope you know what is the meaning of corollary. Corollary means something that already proved. Now we just proved this one, so we'll use this term in a proving in some another format. For example, okay, question number 1 or just Roman number 1, we have to prove that, we will be asked to prove that AB by DB is equal to AC, or we can say AC, not AC, sorry, not same, sorry, it will be EC, okay, or we can say same thing only, whether it's DB by AB is equal to EC by AC. So we just means we have this reciprocal, so DB को हम ऊपर ले गए और AB को नीचे, यहाँ पे दोनों सेम ही है, दोनों बराबर होना चाहिए, okay. So we will prove this one, and number 2 will prove that AD by AB is equal to AE by AC, or we can say इसका जो उल्टा AB by AD is equal to AC by AE. So we'll be proving this with the help of this theorem number 1. This is corollary, means we can prove from the following above the theorem whatever we have done, from there we can do. So from there we can from the theorem 1 we have learned something that, okay, I'm going to draw again, but you don't have to draw it because you have done already you have drawn already once, so it's not needed. Okay, my drawing here, it's not, I don't get any support, so okay, let it be. So we'll draw, we have drawn that one earlier. I'm just showing A, B, C was there, and this was D, and this is E. We prove from there this line and this ratio of these two is equal to this, okay, means combining this. So now we have to prove this one, AB, can you see AB whole, okay, AB whole by DB, and this DB whole by DB is equal to AC whole, and this will be EC, means downside, okay. So you have to prove this one, whether you say from this DB from this side and full side, you can say. This was the question number 1. So we can say now second number, AD, can you see this AD by AB, okay, up to here, and AE by AC, this one. So this is equal, if you can prove from there. Of course, let's see how to prove this one. So for proof 1, okay, we'll be doing this. For proof 1, we'll take from, okay, let's keep going here. We can take where it's going. We just proved this one, isn't it? So let us suppose this is equation number 4. Okay, so we can write, I'm just writing from there, proof 1 from equation 4 in above theorem we have, okay, we have this one, will write, okay, AD by DB, we know about that. We can write AD because of this, AD, okay, by dV. We just prove half of this, and this is equal to this area, and this area, isn't it? Is equal to AE by EC. I hope you have understood. We took from the equation 4. This just we proved this one. Okay. Now we'll do one thing to make it that equal. We'll add 1. Okay. On adding 1 to both sides, we get, you see, this is very easy. If you see it properly, if you're watching for 1-2 minutes, you will not understand it. So we'll just write AD by, okay, this is your dV. We'll just add 1. You see why we are adding 1? Some of you will think, you see, in class 9 we have learned in equality theorem that if there is 2, and suppose there is 2, so if we add 1 this side and if we add 1 this side, so it doesn't make sense. It will be equal. Okay, equality will be there. So we are, if you want to add something in mathematics, then you must add to another side also, otherwise this will not be correct. For example, if just AV by DV is there, so if you are adding 1, you cannot add 1 upside, like you can multiply 2 upside, then you must have to multiply down 2 side. Okay, you have to do like this. If you add, then both side you have to do it, but adding mostly we cannot do because we cannot cut this 2. So multiply we can do it, so we can cancel it, this one, and then remaining the original you will get the same thing, it will not change. Okay, because multiply can cancel out and the remaining will be same. Now, so we have to add both side, AE, EC and plus 1. So let us take LCM. Whenever such thing happens, we have to take LCM. dV, if you divide dV by dV, you will get 1, isn't it? dV divided by dV, cancel out, you will get 1. 1 into AD will be AD. And if you multiply this one, plus, sign is plus, if you multiply directly dV into 1, you will get dV. Same thing here also, EC, you will divide it, you will get 1, so AE and plus EC. Okay, we got this one. I hope you have understood. So now we'll see one thing which is very interesting over here. AD plus dV. You see, AD plus dV. What you will get here? AD plus this one. If you add this whole from, okay, let me show you once. If you add this one, if you add this one, and this is your dV, you can see you are getting AB, isn't it? So I can write AB by dV is equal. Again, when you see AE and EC, if you add this two, you will get AC by EC. Okay, so we have just proved or not, you see, can you see? It's same as it is. Okay, so we can write same thing, because or we can just write, or we can just say dV opposite of this one. If we, because we can do reciprocal of it, if we change movement of this one, will be same. Okay, AB is equal to EC by AC. I hope you have understood this one, that we can prove that one also. Means AB by dV and AC by dV, these are all are equal. Okay, so we'll do some problem based on this BPT, then you may understand it properly. So right now I'm just explaining the concept about this one. So number 2 also same thing. We can just do it by like we can do like this only. Okay, I'm just okay, done. Otherwise we can remove this one. We can remove this one, no problem. Number 2 we can write number 2. We don't have to do it again. Similarly we can just give it similarly by taking reciprocal terms of equation 4. I'm just like summing up here. We will do the similar way. We can prove that AD, same thing I'm writing, by AB is equal to A by AC, or we can say AB by AD is equal to AC by, okay, I'm writing here 2 times AC. This is AE, okay, not AC, by AE. So you just have to find that one, AD. So you just see whether you can get or not. We can prove just by putting over here your equation number 4. You can do whether minus or plus. Just now we have done plus, so you try with minus, you will get the same answer. Okay, so this was your BPT. I hope you have learned. Before I close this one, let me just summing up this part. Remember, okay, remember always, if a triangle is given to you, then if I draw a line over there, then this part is, and this part, ratio of these two part will be equal. Okay, only in case of these two parallel lines are there. Okay, if these two lines are parallel, then only this will be. If these two lines are not, then we will not say all this thing. Okay, so okay, in short, remember this theorem is also called Thales theorem. Another name of this theorem is Thales theorem. Remember this. And someone can ask you what is Thales theorem. So this is same as BPT. It's not the different one. And the second thing we have learned, that this whole area and this ratio we can take, and this whole area, this ratio is equal, or you can say this whole area, or you can say this area, whole area, and this area, you can say these ratios are equal. Okay, I'm just giving you this one which we have done right now here over here to prove this one. Okay, so in here we have just added 1, you can just do minus, and this will be same. And I hope you have understood this chapter properly, and if you understood that, please do like, so that at least I can know you are understanding my videos.